This is lesson 6.3a, addition and subtraction of rational expressions in elementary algebra. And no, my throat is not getting better yet. Alright, let's just start with some examples here. If we have 5 over x plus 3 over x, just like when you had something like this, if your denominators are the same, you just add the numerators and you put them over the common denominator. Denominators are the same, so we add those and we put it over the common denominator. We're going to be doing the exact same thing. The same rule applies, but the only thing is sometimes it's a little bit trickier to find the common denominator when you have variables or letters on the bottom. So let's do one without a letter. Okay, so the key to doing this is break it down into its prime factors. Just the bottom, and then what you do is you look and say, what do I have here that I'm missing here? I have a 2 here and I have a 2 here, so I'm not missing that, but I'm missing a 7 over here because it's there. So I put a 7 here on the top and bottom. Now they both have 7s. Now I look over here and say, what am I missing that I have over here? Well, I've got a 2 and I have a 7, but I don't have a 5, so I'm going to multiply top and bottom by 5. So then this becomes 7, this becomes 15, and this becomes 2 times 5 times 7 equals 22. Add those together, over 70, and then you reduce. Okay? That's it. Now when you're given variables, x's, y's, all kinds of that stuff, you do it the exact same way. That's why I taught it to you this way, so you could do it the same way all the time. You'll even use it in college algebra if you end up going that far. Alright, they're both prime numbers. I can't break either one of those down, so now I look and say, what do I have here that I don't have here? Well, I'm missing a 2. So a 2 on the top and bottom. Now I look here. What am I missing? Well, I have a 2 there and a 2 there. I'm missing the x. Multiply those. Multiply those. Now, if the denominators are the same, I can put them together. Okay? And that ends up being my answer. I can't reduce that any further. So that was example 4. Alright, let's jump to example number 5. That's on the next page here. So let's see if I can get rid of junk here. Alright, so we have 5 over 2x minus 6, and we're adding that. Alright, so first thing you want to do is you want to simplify. So this bottom can be changed to, and the x minus 3 you can't do anything with. I mean, it's kind of there. Let's put parentheses around it though, just to show that it's grouped. Alright, so common denominators. What am I missing? Am I missing anything here? Nope, I've got an x minus 3, I've got an x minus 3. Am I missing anything here? Yes, there's a 2 here. I don't have a 2 here, so I put 1 there. Again, top and bottom. So I'm going to add these two together. 2 times x over 2 times x minus 3. And there I am done. The only thing I might do different is flip these around so it's 2x plus 5 so that my variable comes first. But other than that, that's it. Alright, let's look at example number 6. We've got 1 over x plus 4, and I have plus 8, and then this is x squared minus 16, so I know that it's the difference of 2 squares, so I'm just going to write it as such. Alright, so now I'm going to look and see what I'm missing. I've got to put parentheses around this. I've got an x plus 4 and an x plus 4, so those are fine. Over here I have an x minus 4, but I don't have one over there. Okay, so now on top I have x minus 4 plus 8, and on the bottom I have x plus 4 and an x minus 4. Do not cancel anything, just look at them that way. And let's combine those. Negative 4 plus 8 is just 4 over x minus 4. Okay, now I can cancel that whole group with that whole group. And again, I have nothing on top, so there's a 1. That ends up being my answer there. Okay, a couple more to go and we'll be done. 2 over Alright, so let's simplify that. Okay, and the top cannot be simplified. Difference of 2 squares. Okay, so let's see what I'm missing. I've got an x plus 3 and an x plus 3. I've got an x minus 3 here, but I don't have one over there. Okay. And I have an x plus 3 and an x minus 3. Oh, I don't have an x plus 2. Okay. Let's combine our tops. Okay, so I distributed this x, I distributed this 2 to give me 2x minus 6. And in the bottom, I have x plus 3, x plus 2, and x minus 3. Now notice, because my denominators are now the same, I can write it as one fraction with that one common denominator here. Now let's see what we can do with that. That doesn't look very simplified at this point. So let's get some junk out of the way. Okay, so this is what we have left. I'm going to rearrange that top so it's x squared plus 2x plus 2x. That takes care of both of those 2x's and that. So let's combine these two. See, notice how this just kind of goes on and on and on. Now we're going to take that and see if we can reduce it into two binomials. Two numbers multiplied together give me 6, and added together give me 4. Well, doggone, there aren't any. 3 and 2 give me 6, but added give me 5. 6 and 1 give me 6, but added give me 5 or 7. 6 minus 1 is 5, 6 plus 1 is 7. That being the case, then this is as reduced as we can get, and we're done. Okay, so this is going to be subtraction here, so it's going to be a little bit different. So again, we're going to just simplify everything as much as we can. Difference of 2 squares. Okay, now we're going to look and see what we're missing. I have a 2 here and an x plus 5. What am I missing? I don't have an x minus 5. Alright, now let's look and see. I've got an x plus 5, an x minus 5. I'm missing a 2. So this then gives me and then this gives me a 10. And it's all over . that. So I can't tell if I'm done or not unless I try to figure out if I can combine this with that. So I'm going to multiply this. Okay, so I'm going to use the FOIL method. See if I can get some of this out of the way here. Alright, so x plus 4 times x minus 5. First one's outside, inside, last. These two brought together give me x squared minus x. These two brought together give me a minus 30. Okay, so now I need to see if I can reduce that. Can I make that into two binomials? See, this just seems to go on and on and on. Two numbers multiplied give me 30, added give me negative 1. 6 and 5. 6 times 5 is 30. Negative 6 plus 5 is negative 1. And that's over 2. So see how easy it is for me to come up with the answer and how to make this work? That's because I not only have been teaching this for the past 30 years, but I've been taking classes over this forever. So just because it comes easy to me and hard for you doesn't mean you don't get it. Just realize that it's a lot quicker and easier for me to do. Alright, so now I've got an x plus 5 and an x plus 5. And I'm left with an x minus 6 over 2. I'm left with that, and I'm done. So we're going to skip example 9, don't really see much purpose in that, and bring you into the problem set of 6.3. And gosh, you're doing 13 to 43 odd, I think. Really shouldn't cause you a whole lot of grief there, since the examples I gave are about as hard as you're going to find in any of these. So we'll just call 6.3 good.